According to the National Electrical Code, the resistance between bonded metal objects and the cold water line should not exceed 0.1 ohms for swimming pools or 0.5 ohms for other metal objects. Here's how to determine bonding integrity. Firstly, perform a visual inspection. Inspect the bonding conductor for any visible signs of deterioration, corrosion, or damage. Check if the conductor is properly attached to the cold water pipe and the metal objects. Secondly, perform a resistance measurement. Use a low resistance ohmmeter, typically below 10 milliohms. Disconnect the bonded metal objects one at a time and measure the resistance between the metal object and the cold water line. If the resistance exceeds the acceptable value of 0.1 ohms for pools or 0.5 ohms for other objects, the bond may be inadequate. Thirdly, conduct a continuity test. Use a continuity tester or a multimeter in the continuity mode. Connect one probe to the cold water line and the other probe to the bonded metal object. If the tester beeps or indicates continuity, there is a proper bond. If there is no continuity, the bond may be broken or inadequate. Here's a procedure for evaluation. 1. Visually inspect the bonding conductor and its connections. 2. Disconnect the bonded metal objects in the pool area one at a time. 3. Measure the resistance between each metal object and the cold water line. 4. Compare the measured resistance values to the acceptable limits. 5. If any of the resistance values exceed the acceptable limits, further investigation is required. Since the location of the other end of the bonding conductor is unknown, it is advisable to perform the resistance measurement on all accessible metal objects in and around the pool. If the resistance measurements indicate a possible bonding issue, further troubleshooting may be required, such as tracing the bonding conductor and checking for proper connections. If the bonding conductor is found to be inadequate, it should be replaced or repaired to ensure the safety of swimmers. When assessing the bonding conductor, it is important to meticulously check all connections for corrosion or looseness. Corrosion can significantly increase resistance, undermining the effectiveness of the bonding system. Similarly, loose connections can introduce intermittent faults that are difficult to diagnose. To ensure accurate resistance measurements, it's crucial to use a low resistance ohmmeter capable of resolving values down to milliohms. Standard ohmmeters may not provide the necessary precision for this application. Calibration of the ohmmeter should also be verified to maintain accuracy. When disconnecting metal objects for resistance testing, label each object clearly to ensure proper reconnection. Documenting each measurement alongside the corresponding object is also recommended. This systematic approach helps prevent errors and facilitates accurate analysis of the bonding system. If any resistance values exceed the specified limits, further investigation is warranted. This may involve tracing the bonding conductor to identify areas of damage or degradation. It may also be necessary to examine the grounding electrode system to verify its integrity. In situations where the bonding conductor is inaccessible or concealed, alternative testing methods may be required. These may include using ground fault circuit, interrupter, or GFCI testing equipment to simulate fault conditions and assess the response of the bonding system. Regular inspection and maintenance of pool bonding systems are essential for maintaining electrical safety. This includes periodic visual inspections, resistance measurements, and continuity tests. Any deficiencies identified during these inspections should be promptly addressed to prevent electrical hazards. In addition to the above steps, consider the following points when evaluating the integrity of the bonding conductor. Firstly, ensure that all metal objects in and around the swimming pool are properly bonded. This includes pool equipment such as pumps, filters, heaters, and lighting fixtures, as well as any metal fencing, ladders, or handrails. Secondly, verify that the bonding conductor is sized appropriately for the electrical load. The conductor should be large enough to safely carry fault currents without overheating or causing voltage drops. Consult the National Electrical Code, or NEC, Table 250.102 for guidance on conductor sizing. Thirdly, inspect the grounding electrode system to which the bonding conductor is connected. The grounding electrode system should be properly installed and maintained to provide a low impedance path for fault currents to return to the source. Check the grounding electrode conductor for corrosion or damage and ensure that all connections are tight and secure. Fourthly, consider the effects of environmental factors on the bonding conductor. Exposure to moisture, chemicals, and ultraviolet radiation can accelerate corrosion and degradation of the conductor. Protect the conductor from these elements where possible and replace it if necessary. Fifthly, document all inspections, tests, and repairs performed on the bonding system. This documentation should include the date of the inspection, the results of the tests, and any corrective actions taken. Maintaining accurate records is essential for tracking the performance of the bonding system and identifying potential problems early on. Sixthly, if you are unsure about any aspect of the bonding system, consult a qualified electrician or electrical engineer. These professionals have the knowledge and experience to properly evaluate the bonding system and recommend appropriate solutions. Bonding refers to the practice of connecting all metallic parts within a swimming pool area to create an equipotential plane. This means ensuring that all metal components are at the same electrical potential, minimizing the risk of electric shock to swimmers. The purpose of bonding is to reduce the voltage difference between metallic objects in the pool area. This is achieved by connecting all metal parts to a common bonding grid, which is then connected to the grounding electrode system. The equipotential plane created by bonding helps to equalize the voltage potential, reducing the risk of electric shock. The National Electrical Code, or NEC, Article 680 provides detailed requirements for bonding swimming pools and spas. These requirements cover the types of metal parts that must be bonded, the size and type of bonding conductors, and the methods of installation. It is essential to follow the NEC requirements carefully to ensure the safety of swimmers. All metallic parts within the pool structure must be bonded, including the reinforcing steel in the pool shell, the metal deck around the pool, and any metal fittings or fixtures. In addition, any metal parts within 5 feet of the pool edge must also be bonded. The bonding conductor must be made of copper and must be sized according to the NEC requirements. The conductor must be installed in a continuous length, without any splices or joints. All connections must be made using listed connectors suitable for the application. The bonding grid must be connected to the grounding electrode system, which consists of one or more grounding electrodes. The grounding electrodes must be installed in accordance with the NEC requirements. Common types of grounding electrodes include ground rods, ground plates, and concrete encased electrodes. Regular inspections and testing of the bonding system are essential to ensure its effectiveness. The resistance between any 2 points in the bonding grid should not exceed 0.10 ohms. If the resistance exceeds this value, it indicates a problem with the bonding system that needs to be addressed. When measuring resistance, use a low resistance ohmmeter capable of accurately measuring values in the milliohm range. Ensure that the ohmmeter is properly calibrated and that the connections are clean and tight. In addition to resistance measurements, visual inspections should be performed regularly to check for any signs of corrosion, damage, or loose connections. Any problems identified during these inspections should be promptly addressed to maintain the integrity of the bonding system. When performing bonding work, it is essential to follow proper safety procedures. Always disconnect the power to the pool equipment before working on the bonding system. Wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working on electrical systems, it is best to hire a qualified electrician to perform the work. Bonding is a critical component of swimming pool safety. By following the NEC requirements and performing regular inspections and testing, you can help to ensure the safety of swimmers and prevent electrical hazards. Remember, if you are unsure about any aspect of pool bonding, consult a qualified electrician or electrical engineer for assistance. These professionals have the knowledge and experience to properly evaluate the bonding system and recommend appropriate solutions to ensure the safety of the pool. Furthermore, consider the impact of chemicals used in the pool on the bonding system. Chlorinated water can be highly corrosive and can accelerate the deterioration of metal components, including the bonding conductor and connections. Regular water testing and maintenance are essential to minimize the corrosive effects of pool chemicals. Use appropriate chemical feeders and controllers to maintain proper water balance and prevent excessive chlorine levels. Consider using corrosion-resistant materials for the bonding conductor and connections. Copper conductors with a protective coating, such as tin or nickel, can provide enhanced resistance to corrosion. Stainless steel connectors and fittings can also be used to minimize corrosion. When installing the bonding conductor, protect it from direct contact with concrete or soil. These materials can contain chemicals that can corrode the conductor. Use a protective conduit or sleeve to isolate the conductor from the surrounding environment. Implement a regular maintenance program for the pool bonding system. This program should include periodic visual inspections, resistance measurements, and continuity tests. Document all inspections, tests, and repairs performed on the bonding system to track its performance and identify potential problems early on. Educate pool users about the importance of avoiding contact with metal objects in the pool area during electrical storms. Lightning strikes can pose a significant electrical hazard, and it is essential to take precautions to minimize the risk of injury. Post warning signs around the pool area to remind users of this safety precaution. Finally, stay informed about the latest developments in pool bonding technology and best practices. Attend industry conferences, read technical publications, and consult with experts to keep your knowledge and skills up to date. This proactive approach will help you to ensure the safety and reliability of the pool bonding system. The bonding conductor's size matters significantly. The National Electrical Code, or NEC, dictates the minimum size of the bonding conductor based on the size of the circuit conductors supplying the pool equipment. Using an undersized conductor can compromise the effectiveness of the bonding system and increase the risk of electrical shock. Refer to NEC Table 250.102 to determine the appropriate size of the bonding conductor for your specific application. The type of connection used for bonding is also critical. All connections must be mechanically sound and electrically conductive. Use listed connectors specifically designed for bonding applications. Avoid using wire nuts or other unapproved connectors, as they can loosen over time and create a high resistance connection. Ensure that all connections are clean and free from corrosion before making the connection. Use a wire brush or other cleaning tool to remove any dirt or debris from the conductor and connector. Apply a corrosion inhibitor to the connection to prevent future corrosion. Proper installation of the grounding electrode system is essential for effective bonding. The grounding electrode system provides a low impedance path for fault currents to return to the source, minimizing the risk of electrical shock. Ensure that the grounding electrode system is installed in accordance with NEC requirements. Common types of grounding electrodes include ground rods, ground plates, and concrete encased electrodes. The number and spacing of grounding electrodes must also comply with NEC requirements. Regular testing of the grounding electrode system is essential to ensure its effectiveness. Use a ground resistance tester to measure the resistance of the grounding electrode system. The resistance should not exceed 25 ohms. If the resistance exceeds this value, it indicates a problem with the grounding electrode system that needs to be addressed. Consider the location of the pool when designing the bonding system. Pools located in areas with high soil resistivity may require additional grounding electrodes to achieve the required ground resistance. Pools located near underground utilities may also require special bonding considerations to minimize the risk of electrical interference. In addition to the above considerations, it is important to follow all applicable local codes and regulations when designing and installing a pool bonding system. Local codes may have additional requirements beyond those specified in the NEC. Consult with your local building department or electrical inspector to ensure compliance with all applicable codes and regulations. Consider using a qualified electrician or electrical engineer to design and install your pool bonding system. These professionals have the knowledge and experience to ensure that the system is properly designed and installed in accordance with all applicable codes and regulations. Investing in a professionally designed and installed pool bonding system is a worthwhile investment in the safety of your family and friends. It can help to prevent electrical shock and other hazards associated with swimming pools. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before designing or installing a pool bonding system. Remember, electrical safety is paramount when it comes to swimming pools. By following the above guidelines and taking the necessary precautions, you can help to ensure the safety of everyone who uses your pool. The bonding system should extend beyond the immediate pool area. Equipotential bonding aims to minimize voltage gradients in the vicinity of the pool, reducing shock hazards even outside the water. Extend the bonding grid to include metal objects within a defined perimeter around the pool, as specified by the NEC. This perimeter typically extends several feet beyond the pool's edge. Consider the presence of nearby metallic structures, such as fences, gates, and lighting poles. Bond these structures to the equipotential grid to further enhance safety. Special attention should be given to areas where people are likely to be barefoot, such as pool decks and walkways. Ensure that all metal objects in these areas are effectively bonded to the grid. The depth of the bonding conductor is also an important factor. Vary the bonding conductor at a sufficient depth to protect it from physical damage and corrosion. The NEC specifies the minimum burial depth for bonding conductors, which varies depending on the location and type of conductor. Backfilling material should be carefully selected to avoid damaging the bonding conductor. Use clean, non-corrosive backfill material that is free from sharp objects and debris. Compacting the backfill material can help to protect the conductor and prevent settling. Consider using a tracer wire alongside the bonding conductor to facilitate future locating and maintenance. The tracer wire can be connected to a signal generator to allow for easy tracing of the bonding conductor's path. Document the location of the bonding conductor and tracer wire on a site plan for future reference. This information can be invaluable for maintenance and repair purposes. Regularly inspect the bonding conductor and tracer wire for damage or corrosion. Replace any damaged or corroded components promptly to maintain the integrity of the bonding system.